The technique we are discussing today is something you definitely shouldn't miss, because we will teach you an exclusive strategy that can elevate the motion effects of Wan 2.2 video generation to a completely new level. Now take a look at these videos. The motion effects in these videos are completely different from the results generated using the traditional Wan 2.2 workflow. This applies both to the overall expression of movement and to the slow motion problem we previously discussed. Both issues will be effectively improved in our workflow. I have also built the workflow onto Running Hub. You can access this platform through runninghub.ai. In the field of ComfUI, Running Hub is an excellent online working platform because as soon as new technologies and new models emerge, it will follow up immediately. You can register for Running Hub using the invitation link in the description section of my video. This way, you can receive 1,000 free points. Furthermore, logging into Running Hub daily will also give you 100 bonus points, so you can try out your own workflows. Alright, now let's take a look at this workflow. Structurally speaking, this workflow is a Wan 2.2 image to video workflow. Take a look at this image. We encountered this image in a previous video. It features a beautiful woman with a fantastic dragon image behind her. Let's look at the generated effect. First of all, it doesn't have the slow motion problem. Secondly, notice that the motion effect is quite astonishing. It is not like the results generated by the traditional Wan 2.2 workflow, where the generated character only displays a single action. While the quality of the character might be high, the range of motion is often lacking. To achieve this level of motion, we need to combine 4 techniques. As we break down the entire workflow, we will explain each technique in detail as we encounter it. Let's first look at the data processing section. Here, we set the width and height. I still recommend using 544 and 960 resolutions like 832 and 480 actually result in a certain degradation of the generation effect for the Y2.2 model. They are not particularly good. Of course, you can also use 720 and 1280, but that entirely depends on your computational power. Our total number of frames is 81 frames. We are now going to resize this image, primarily to keep it aligned with our resolution. Let's look at model loading. This is a very important step in how the video gains more motion effects. First, let's look at the main model. We are currently using the Wan 2.2 ATV model. This is the high noise model, and this is the low noise model. Next is our acceleration Lora. For this acceleration Lora, we are using a light image to video acceleration Lora, specifically the Light X2V version. Its rank value is 64. Please note, although this acceleration Lora is Light X2V, it is not the official one. This one is provided by Qwen, and you can download this Lora via the provided website. Note that we are using the I2V rank 64. Now for the key point, in order for it to achieve more motion effects, we set this Lora strength very high. You must note that I am using 5.0 here. Similarly, the low noise model also uses the same Lora, and its weight is relatively high as well, currently set at 2.0. This method of parameter setting is a completely unconventional approach. So this is the first key point, Lora strength. Working alongside it, we used another Lora. For this Lora, we utilized a technique called Pusa. We have discussed this technique more than once before. What you are seeing now is Pusa, the GitHub page for this technique. We mentioned before that its most innovative technology is called VTA. How should you understand it? It primarily optimizes the scheduling of time. We have also given an analogy before. What is VTA? For example, a video generally has one progress bar. This progress bar represents the state of video progression. VTA takes a video that only has one progress bar and refines it so that every single frame has its own progress bar. Therefore, every frame has its own individual time scheduling, which allows it to have more motion effects. This model now supports Wan 2.2. You can find the corresponding model in Qwen's Hugging Face repository. This one is for 2.1 and this one is for 2.2. Similarly, the one above is a Lora for the high noise model, and the one below is a Lora for the low noise model. Furthermore, I set its weights quite high. Everyone can set them around 1.5. Generally, we set the high noise model slightly higher and the low noise model slightly lower. Why? Because the high noise model is responsible for motion planning, and it is more effective at enhancing motion effects. The low noise model primarily optimizes the video, so its relative weight can be set slightly lower. So what you see now is this one has a weight of 5.0, this one is 1.5, and this one is 2.0, and this one is 1.4. Of course, setting this one to 1.5 or 1.2 is also fine. Then, according to our previous design strategy, we use CFG 0 star above, and I use Sage Attention below. Below that are our text encoder, Virginia E, and our visual encoder. The second crucial point is how the prompt is written. The prompt writing must contain many descriptions of actions. Here, we used an image-to-video prompt engineering strategy that we wrote previously. Using this prompt engineering, we drive the Qwen VL model to generate a JSON formatted prompt. To make it clearer for everyone, I will run it now. Let's look at the generated prompt. The most critical element in this prompt is something called action sequence. What does that mean? It means the sequence of actions. We designed an action for every second. Therefore, compared to traditional prompts, this prompt will yield more motion effects. This is also a very important step. After encoding, we naturally obtain our positive condition and our negative condition. Next, let's look at the next crucial technical step here. We utilize Painter I2V. We have discussed the Painter I2V technique in a previous full video. Its main purpose is to solve the slow motion problem. Therefore, we use it to replace the traditional Vyman video encode node. Please note, the motion effect magnification factor I am currently setting is 1.35, which is relatively large. We pass our positive condition and negative condition to it, and then we can generate a new positive condition, negative condition, and our latent. Below is the sampling section. This sampling is a standard sampling process and is not special in any way. We use 6-step sampling. The first 3 steps sample the high noise model, and the latter 3 steps sample the low noise model. My sampler algorithm is LCM, and the scheduler algorithm is simple. This results in a fantastic effect. Now, let's summarize. If you want to achieve these motion effects, there are several key points, mainly categorized into 3 groups. The first group is related to the Lora settings. For the Light X2V acceleration Lora, we used very high coefficients. The high noise model used 5 and the low noise model used 2. Furthermore, we used Pusa where the weights were also set high, 1.5 and 1.4 respectively. The second key point is our prompt. The essence of prompt optimization is to generate as many action descriptions as possible. Of course, you don't necessarily have to use my prompt engineering method. You can use any other method as long as the resulting prompt gives you more motion effects. Thirdly, we used Painter I2V to solve the slow motion problem. If you are unfamiliar with this technique, you can watch this video which provides a very detailed explanation. Perhaps some people might think that this is a special case. I have run many tests for you, so let's take a look. This is an image of a beautiful woman standing on a giant rock. We used this example before when discussing the SAM 3D technique, and the motion effect there was also sufficient, but that required a Uni3C driver. This current example, however, does not. It is purely a standard image-to-video workflow, and we still achieved a fantastic result. Let's look at this one. This is a very dreamy image. The foreground character is realistic, and the background features a Chinese ink wash painting style. It is very beautiful. Let's check out the generated effect. Notice the clarity of the character's face, and I think the expression of the overall movement and the colors are excellent. We tested 3 vertical videos. Let's look at the horizontal screen effect. Look at this. This image is classic. A beautiful woman and a luxury car, right? A beautiful woman leaning on a sports car in a beach scene at sunset. Let's see the generated result. It features a significant camera movement, and the character also has very rich movements. Note that the waves in the background are also rendered very accurately. Now look at this one. This is a runway model. She is standing on the catwalk and performing a turning motion, causing her skirt to flare up. Let's look at the generated effect. The character has richer motion effects, and the audience members next to her also show fantastic movement. This perspective is quite classic. A beautiful secret agent standing on the edge of a tall building, looking as if she is about to jump. Generally, if we use the Wan 2.2 I2V model, how would this be presented? She would probably just jump across, and that would be it. But notice, the generated effect is completely different. She jumps across, but there is a display of the next part of the story. She jumps onto a ladder. Take a look. It's fantastic. After so many tests, everyone can see that this combination is very effective. Although we used very strong Lora weight coefficients, this did not cause the overall video quality or movement to become distorted. On the contrary, we achieved excellent results in enhancing motion effects. The video you are currently watching was the first video I generated by combining these techniques. I was truly impressed at the time. I believe I found a very effective method for boosting the motion effects of Wan 2.2. Therefore, I am sharing it with everyone in this video. I hope it will be helpful for your video generation. So, what are you waiting for? Go ahead and try it yourself. Follow me and become someone who understands AI.